Good afternoon, everybody.
I'm Max Holden. I'm from Los Angeles, California. I am representing Chaminade College Preparatory, where I just completed my sophomore year. And for those of you here last year, you might remember this experiment, and it's testing the effects of microgravity on fermentation rates. So we were given our groups and told to pick a topic, and my dad's been collecting wine his whole life, so I immediately thought of fermentation. But I had to think of the simplest way to test it because the FME tubes aren't very complicated. And the simplest way did turn out to be wine. So I came up with the question, does microgravity affect the speed of ethyl fermentation? Okay. My hypothesis being that due to the constant speed the experiment will be in, that the experiment's rate will increase in microgravity. This is the design. We use the type FME3. The type 3 FME tubes, which contain the main volume. The main volume had two smaller glass tubes, one containing yeast, one containing neutral buffered formalin to stop the experiment, the main volume containing grape juice. The first tube would be broken so that the yeast could react with the grape juice and start the fermentation. The formalin was used to get exact time on both experiments, the ground truth and the International Space Station. And then once it came back, we were going to test which one fermented more by testing the dissolved carbon dioxide using a titration kit. So once we had our whole setup, we had to find the correct amounts because in the beginning there were issues with the possibility of the tubes popping off and the tops launching off due to CO2 buildup, and we got emails from SSE saying that could be a problem. So we had to first get an amount that could sit for a few months without having any CO2 buildup. And then once we had those levels to where it was impossible for the top to pop off, we needed to establish a time frame so that the fermentation levels wouldn't even out. Because if they were even out, then we wouldn't get exact levels. So we had to run a few more tests. And we decided that 2 days was a good time to where there was still a good amount of fermentation left in both experiments. And then this was the data we got. These are the exact amounts. These just went on there for some reason. Purple line is the International Space Station. This is the ground truth. It's in parts per million. There were 800 parts per million in the ground truth and 2,500 parts per million of carbon dioxide in the space station. This meaning that the fermentation rate increased by a little over 3 times, which is a fair amount. So what does this really mean? If you ask adults will say that when we have to live in space, they can make their alcohol quicker. If you ask me, I'd say that it can make more potent biotech drugs that are now fermented, along with possibly making it quicker in case of outbreak in which we needed our fermented biotech drugs quicker. We have the possibility of using a microgravity chamber and speeding up the reaction. I would like to thank the following: teacher facilitators, our families, Medtronic, Chaminade, SSEP, and the Smithsonian.
Anybody have any questions for West Hills, California team? Let me also, by the way, say, Max, were you here last year too?
I was.
Yes, because I remember you.
Yeah.
And this is a really, really good, also teachable moment. This was a Mission 1 experiment, and you were here last time before it flew.
Yeah.
Right?
No. It flew last time, but we didn't get results.
Yes. Okay. So what happened is, we
Yeah.
didn't have activation by the astronaut. So this was a reflight. So last time you could only report on your experiment design, and now this conference you're actually reporting experimental results, which is saying that those of you that are reporting on experiment design now prior to flight, please come back next year and report to us what the results were, because that's what this conference is all about. The other thing that I wanted to pass on is that NASA Johnson Space Center has contracted for a special article on science return from the Student Spaceflight Experiments Program. And there is a reporter that keeps hounding me, a writer, who wants to know what the results were, and we didn't know a priority before this conference because we're only hearing the conference results now. So you and the HBOC team and the other teams that are reporting out flight results, you need to send me an email because we want to get you in that article and report back to NASA.
Hey, I'm Dave Esslinger from North Charleston. Great job.
Thank you.
Interesting experiment. And you've kind of talked about fermentation and what most of us see as the beneficial effects of fermentation. However, for long-term spaceflight, the fermentation is also a spoilage factor. Have you given any thought to that and how it might, how your results might impact any long-term spaceflight plans?
That was a problem that I did see, how food spoilage could be increased in space, how you have less time before your food goes bad. That was a problem we saw, and we didn't really find a way to fix that because the rates were so much higher that food can go bad 3 times faster, maybe even quicker.
All right, let's thank the team from West Hills, California.